My postdoc is with the University of Waterloo School of Pharmacy, but I also do a lot of collaboration still with the University of Guelph Department of Food Science. And the reason for that is we have a piece of equipment that's state of the art, that's very exclusive. There's only about 3 in Canada, and we have the pleasure of having one of them here. And it's a system that's called the TIM-1 in vitro simulated gastrointestinal digestion model. So essentially, what this system does is it simulates the stomach as well as the intestinal portions of digestion. And so this allows us to develop novel drug delivery systems incorporating plant bioactive compounds, including cannabinoids, and to rapidly assess for their potential bioavailability and rates of absorption into your system. So this is a great tool that we have that allows us to innovate at a much faster rate without having to go through issues concerning ethical concerns and human and animal trials. So that's all I want to say about myself. And so we'll start off with some of the fundamental discoveries in the world of cannabis research. And so it all started in 1941 with the discovery of cannabidiol and cannabinol, which was isolated by an American scientist, Adams, and this occurred in 1941. But what they knew right then and there was that this wasn't the compound that was involved with the psychoactivity caused by cannabis. So in 1964, Raphael Mechoulam, who's now infamous, who's now known as the father of THC, over in Israel discovered tetrahydrocannabinol, THC, which is obviously the main active compound in cannabis. So not only did he discover and isolate THC, he also produced a synthetic version of THC. And this was quite groundbreaking because it allowed other labs to also study cannabis and in particular THC. So this really advanced research in this area without having to obviously go through the legal constraints of obtaining cannabis to work with in the lab. So having said that, they've discovered THC, CBD, the 2 main compounds in cannabis. So now they wanted to figure out how this worked on the human body and the human brain in particular. So in 1986 and in the early 90s, 2 different groups discovered the CB receptors. And these were the receptors that were in our brain, in our bodies, that are able to communicate with THC and CBD and other cannabinoids. Also, at the same time, Mechoulam wanted to know if we had a naturally derived cannabinoid system in our body. And so this led to the discovery of endocannabinoids, namely 2-AG and AEA. So endo meaning from within. So these are cannabinoids that we produce naturally in our bodies. To highlight the importance of the endocannabinoid system, I take you to a quote here at the. This was published in 2013 in a review paper. So it says that based on preclinical scientific evidence, modulating endocannabinoid activity may have therapeutic potential in almost all diseases affecting humans. And so this is a bold statement, and we'll talk a bit more about the endocannabinoid system in general. So now I want to talk about the cannabis constituents. And so we obviously know of THC and CBD. So far, other than that, we also know that there are more than 100 different phytocannabinoids. THC obviously being the main compound that induces the psychoactive effects of cannabis. CBD is also very important. It can modify the effects of THC. CBD on its own has also some potential therapeutic effects, as we'll discuss later on. Cannabinoids are produced in the glandular or captate trichomes. They're better known as the crystals. They're mainly found in female plants. Another group of compounds called terpenoids. These are known to impart the sense of smell and flavor to cannabis flower, but recent evidence has shown that terpenes can also have anti-inflammatory, anti-anxiety effects on humans. But also, in terms of the plant physiology, terpenes can also be a protective agent in that it has some antibacterial properties. So, taking a closer look at THC-type cannabinoids, like I said, we know of THC very well. But what's interesting is that THC is actually present at very low concentration in the raw plant. What we actually find in the plant is the precursor to THC, which is known as THC acid or THCA. It's essentially THC but with a carboxylic acid group. So THCA actually does not have any psychoactive effect. So we tend to ignore THCA, and something that it's always been viewed as undesirable. So we want to decarboxylate, remove the carboxylic acid group in order to activate THC. But recent research has suggested that THCA can actually have anti-inflammatory activity and is able to suppress inflammation more so than THC itself. And that's the result of the figure that we show here. So this is measuring TNF alpha, which is a marker for inflammation. And so when it's stimulated, when the cells are stimulated with a lipopolysaccharide or LPS, we see an increase in inflammation markers. But when we co-administer this with THC or THCA, we see that the levels of TNF alpha is decreased. And this suppression of inflammation is greater when the cells are subjected to THC acid compared to THC. Also, recent research in the Department of Neuroscience at the University of Guelph, led by Dr. Linda Parker, has also shown that THCA is more potent at alleviating nausea and vomiting induced by chemotherapy. And so this is studies that were done on a mice model, and she has very good mechanistic explanation as to what is happening there. Also, another minor compound that's related to THC is tetrahydrocannabivarin, THCV. So recent research again shows that it can suppress food intake and reduce body weight. So this is somewhat counterintuitive to what is previously believed to have believed in terms of cannabis inducing appetite and increasing appetite. And so this compound can potentially have therapeutic effects in terms of obesity and diabetes. Its mode of action is similar to a previously approved drug known as rimonabant, but THCV has far less side effects and doesn't produce neither nausea nor anxiety.
Sorry, Peter, just before you move on, because
Sure.
yeah, if you don't mind going back, I don't know about anybody else in the audience, but this is quite novel information for me, the idea that the acidic form of THCA, actually may have more therapeutic effects. So as patients
Mhm.
who, and myself included, we want the medicinal effects, but we're not after the high or the psychoactive effect. It might be better for us to actually just consume not, carboxylated THC,
That's right. Yeah.
THCA. That's very interesting. If you have had or have tried this, anybody in the chat have used THCA specifically, let us know. We'd love to hear about that. Anyways, go ahead, continue.
Okay. Yeah. So no, it's so this is obviously something that is performed on mice, and the results are very encouraging. So they actually found that in terms of CBD, so similarly here, CBDA, so the precursor to CBD, they found that it's 100 to 1,000 times more potent than CBD in reducing symptoms of vomiting and nausea in an animal model after they've been, after they've had chemotherapy treatments. What's interesting here is that the reason we decarboxylate is that THCA and CBDA are not able to bind and react to CB receptors. And this is something that is known. There's a lot of studies on the affinity of THC versus THCA to CB receptors. And so the question here is what is the mechanism behind CBDA and THCA's activity, right? If it can't interact with the CB receptors. So what they found is there's actually a complementary set of receptors known as 5-HT1A. So it modulates activity through a different mechanism. Anyways, if you like the papers, feel free to ask me for the links to that afterwards. So CBD again is the primary non-psychoactive cannabinoid. So a lot of research have suggested there's therapeutic potential there in terms of managing anxiety, inflammation, nausea, inflammatory pain, and epilepsy. So moving on, so we'll talk a bit about decarboxylation. So despite what I've said previously about THCA and CBDA, decarboxylation is still something that's very common. You still want to decarboxylate THCA in order to produce THC so that it can bind to the CB receptors and have the effects that we're all used to. So you simply do this, as I'm sure some of you already know, you simply do this by heating up the raw plant material. There's a lot of studies looking at different temperatures, how time of the heating can affect the rate of decarboxylation. Everyone seems to have, their sweet spot depending on the strain that they have. Another thing that's worth noting too is that, in Canada anyways, when we buy medicinal cannabis from licensed producers, on the label, it'll tend to say the potential concentration of THC and CBD. Because like I've said, in the actual raw plant, the concentration is actually very, very low in terms of THC and CBD. So it's good to be aware that what they typically label in the big font is actually what the concentration will be once it's been fully decarboxylated. So just something to be, I guess, aware of. So moving forward, the endocannabinoid system. So I'll spend some time on this because this is a very, very important system. So the reason that it's called the endocannabinoid system, like I've said, is obviously endo meaning from within, and it's endocannabinoid because it was discovered when they were trying to figure out how cannabis interacted with the body. But in fact, if let's say cannabis had never existed, we would still have this system in our brain and in our bodies. So CB1 receptor is predominantly found in the brain, whereas CB2 receptors are mainly found in peripheral organs. And these receptors are very abundant. In fact, CB1 receptors are the most abundant receptor in the brain. So one has to wonder from an evolutionary perspective, why did humans develop so many CB receptors? And it can't just be so that we can interact with cannabis and feel its psychoactive effects. So what they found was that the endocannabinoid system actually has a role to play in many aspects in terms of learning, memory, anxiety, fear, nausea, pain, etc. So how this works is that this is research that's been, again, done by the Department of Neuroscience at the University of Guelph, where they proposed a mechanism. So taking nausea as an example, they found that when an endocannabinoid, for example, 2-AG, is secreted, it'll act locally on a CB1 receptor at the insular cortex where the source of nausea is occurring. Once this receptor is activated, it'll reduce the levels of serotonin, which is responsible for nausea. And so it's this type of regulation that occurs at different areas of the brain, and that's how we have the effects when it comes to pain, anxiety, fear, and all these other symptoms. What they also found is that if you can somehow sustain and continue this release of endocannabinoids, you can have a greater therapeutic effect. And so what they found was that there are enzymes that regulate the secretion of these endocannabinoids so that they are only produced when they are needed. And then when they're no longer needed, this gets shut down. But what they found is if they're able to come in and inject a enzyme inhibitor, they can sustain the release of these endocannabinoids so as to have a greater therapeutic effect. So how these are endogenous cannabinoids. So when we smoke or ingest cannabis, what happens is the cannabinoids will interact with all the CB receptors that it encounters at all different parts of the brain. And so that's why we have a whole host of side effects. So the key moving forward for this kind of research is how do we fine-tune the effects of cannabis so that it can have a localized effect depending on if the patient needs relief from pain or anxiety or depression or nausea, etc. So next we'll talk about bioavailability. And so it's nice to have all these effects, but one has to first ingest the cannabis and it has to enter into circulation. And so bioavailability measures the proportion of a drug that enters the circulation when introduced into the body and is able to therefore have a bioactive effect. So what's also important is a term called bioaccessibility. And so this bioaccessibility essentially comes before bioavailability. So if you imagine you have an edible cannabis product, the bioaccessibility will measure the release of the cannabinoids from the food matrix, its transit during digestion, so its ability to survive digestion and then have that potential to then be bioavailable. So essentially, if you have zero bioaccessibility, you have, in effect, zero bioavailability. So looking at some of the numbers here, so theoretically, if you were to inject THC intravenously, you would have 100% bioavailability because it avoids digestion, it enters into the bloodstream right away. If you were to inhale cannabis by smoking, based on an accumulation of data, the bioavailability of THC is around 2 to 56%. So we see a large gap here, and that has to do with individual users having different, the amount of smoke that they inhale, how long they keep it in their lungs. That is all subject to creating this, big discrepancy in the results. When you ingest cannabis in the form of an edible, the bioavailability is about 4 to 20%. So on average, when you inhale cannabis, you get a higher bioavailability according to the data that's currently available. And we'll talk a bit more now about where these numbers come from and what do they mean. When you smoke cannabis, so you get a very quick response. So within 6 to 10 minutes, the THC reaches peak plasma concentration, and it averages out after 15 minutes of smoking. And the reason for this quick response is because in our lungs we have alveoli, and these are very thin, air sacs that are responsible for the gas exchange. They also have a large surface area, so it makes it very easy for THC to enter into the bloodstream. Once it's into the bloodstream, some of it does end up into the liver, where it becomes metabolized to 11-hydroxy-THC metabolites, and this is the active metabolite. Some studies have said that it has it's equipotent or of the equal potency to THC, but other studies have also suggested that it's actually more potent than THC. So it really depends on the study that you look at. When it comes to ingesting ingesting cannabis, the effects are delayed. So you begin feeling the psychotropic effects about 30 to 90 minutes after ingesting. The peak plasma concentration is achieved in 2 to 6 hours, but the effects can last as long as 12 hours. And so the reason for this is when you ingest THC or cannabis, it has to go through the entire digestive process. And so it'll enter into first pass metabolism, where a lot of the THC can be excreted in the urine, for example. In the same process, you actually end up producing a lot more 11-hydroxy-THC metabolites. In fact, you produce 3 times more compared to when you smoke. And if you were to believe that 11-OH-THC is more potent than THC, this could explain why the psychoactive effects of ingesting cannabis products is different compared to smoking cannabis products, as has been mentioned anecdotally in the past. Another thing to consider when it comes to edibles is whether or not to consume with food. So when it comes to pharmaceutical drugs, it's often labeled on the side of the bottle to take with food or to not take with a meal. And based on studies that have looked at the bioavailability of THC and CBD in the fasted state versus in the fed state, the results are rather conclusive, suggesting that it is best to take an edible product on a full stomach or with a meal. And the reason for this is, if you look at the chemical composition of cannabinoids, particularly THC and CBD, they are considered very lipophilic, and so they're essentially fats or lipids. They don't dissolve very easily or at all in an aqueous solution. And unfortunately for that, when in the gastrointestinal fluids, it's essentially all aqueous. And so that's why it really hinders its ability to be absorbed into our system. But when you eat a high-fat meal, this triggers your body's response into producing more bile. And bile is an important emulsifying agent of fats. So it has a nonpolar group as well as a polar group. And so if you can imagine, the nonpolar group will surround the THC or CBD, which are also nonpolar. And then the polar tail will help it dissolve in water. And so this will improve its ability to dissolve and to be absorbed into our body. Also, anecdotally speaking, a lot of people have said that when when they haven't eaten in a while and when they consume cannabis edibles, they feel the effects much quicker. And in fact, if you look at the figures here, you do see that in the first hour, in the fasted state, the plasma concentration is in fact higher for those individuals in the fasted state. But of course, over time, in the fed state, that's where you end up absorbing most of the THC and CBD.
Uh, Peter, just want to
Yes.
ask a quick clarifying question from Nick. He asks, bile has the same effect as, I'm not sure how to say that, lectin?
Well,
Something like that?
yeah, so that's a phospholipid.
So he's just
It
asking for
is similar in
clarification.
structure. Yeah. Um,
Okay.
does it have the same effect? I mean, when you look at the structure of a phospholipid, it is in fact a polar or nonpolar group with a polar tail. But bile has a lot more in it, so it has bilirubin. It's a very complex biological mixture of of compounds and secretions. So and it's obviously produced in the
All right.
gallbladder,
Hopefully,
so
Nick, that
it's a
answered your
yeah.
question. Let us know if you need any further clarification.
Okay, is that okay?
Cool. Great.
So moving on.
Oh, yep. He said he
Um,
answered his question.
Another
Thank
study I
you.
want to
Yeah.
just show is the difference between vaporized and smoking. And so this study looked at the absorption of THC at different concentrations in individuals that vaporized versus those that have smoked cannabis. And we find that the plasma concentration is actually very comparable between the two methods of inhalation. They also looked at the levels of carbon monoxide that was released. And obviously, the levels of carbon monoxide released from vaporizing is essentially none. So it's a much safer alternative without compromising the bioavailability of THC. So, following along with that trend, I think there is certainly a movement towards non-smoking alternatives when it comes to consuming cannabis. And so now we'll just talk a bit about what the science says about some of these alternative methods to consuming cannabis products. And so one method of consuming cannabis products, I suppose, is cannabis suppositories. So there's been a lot of buzz surrounding, rectal administration of cannabis. When we look at some of the results from studies, so I was surprised to find that there's been studies dating as far back as 1991 looking at cannabis suppositories. So they tested this on monkeys, dogs, as well as humans, and the results are overall very positive. So when we look at the bioavailability of THC in monkeys, it's 13.5%. In dogs, it's very high at 50 to 60%. And in humans, they unfortunately only tested 2 humans. So the sample size is very small. But in both cases, they found that it was twice as high as compared to oral ingestion. And so how, when you administer it rectally, it gets absorbed into the rectal mucosa. It can reduce first pass metabolism of THC into 11-OH-THC metabolites. A lot of people have also said that it bypasses the head high. You don't get the head high. It's more of a body high. So what I would say as a caveat to to all the positive information that's surrounding cannabis suppositories is that these 3 studies, they all used pure delta-9 THC that they reformulated into a prodrug hemiester. So they actually are using delta-9 THC hemisuccinate, which is something that, isn't obviously readily available. There isn't any study looking at whole plant extract. And so some of the DIY methods that I've seen online, it's simply take cannabis oil and putting them into suppository form. So there's no evidence of that having the same effects as this delta-9 THC hemisuccinate. And so I would caution, these results seem really good, but I would caution how realistic these numbers actually are. And, that's somewhat the same sort of message, I would say, for all these alternative routes. There simply isn't enough research that's gone into it. And a lot of times you end up paying a premium for some of these, these products without necessarily understanding how they work and how well they work. So sublingual mist is something, sublingual sprays, I should say, is something that is also available in Canada. There is one licensed producer that currently sells sublingual sprays. And so the theory behind it is great. So you apply the spray under your tongue, and it's supposed to have a very quick onset of effects because there's a lot of capillaries under your tongue, so it enters the bloodstream very quickly. The problem is when they did the study looking at the bioavailability of sublingual sprays versus oral ingestion, they found that the bioavailability is very similar. And the reason for this is it's very hard for us to not, swallow the spray. So there's reflex swallowing that's occurring. And so when that happens, you end up essentially ingesting the spray much the same as you would any edible products. Transdermal patches is something that's very common for nicotine patches.
That's a bummer.
Sorry. Oh. So there's a lot of there's a lot of positives when it comes to transdermal patches.
That's upsetting. Never mind.
Okay. So you can really control the dosage. There's no user error here. You simply apply the patch. You don't have to worry about it. It can control the dose, the release over long periods of time. So far, right now where we're at with this technology is it can only be applied to small doses. So we're only able to load a very small dose. We're looking at milligram per day or less onto these patches. So you'd have to have multiple patches, I suppose, is one way around this issue. Another product that is on the rise are lotions and balms, and so there's currently no studies available on these. Theoretically, though, there are CB receptors on the skin at the skin level, and so it could interact with those CB receptors. It would obviously be a localized analgesic effect. It wouldn't enter the bloodstream, so you're not going to feel the psychoactive effects. Again, it would be very much a localized effect because it can only penetrate the skin but not into the bloodstream. And so I see there's a lot of questions building up, and that's essentially the end of my talk. So I guess I'll open it up to questions. Is that okay?
Yeah, absolutely. Let me bring some up that came up earlier in the conversation. So Tony was asking about THCA and whether or not it can be absorbed transdermally as well. So a lot of lotions and salves are being used for inflammation of ligaments and muscles, and if THCA has been proven to have a little more of an anti-inflammatory effect, can it be absorbed through the skin the same way that THC can?
So that's a really good question, and we don't have the answer to that yet. So THCA, you have to understand THCA and CBDA, these are all sort of, the research into that is very much at the level where they're still just testing it on animal models, right? They haven't actually looked into how to turn THCA and CBDA into applications. And so we are definitely far away from turning it into lotions or anything for a transdermal application. If there's positive effects, I think the first thing that would happen would probably be to make cannabis oil that haven't been decarboxylated, before we start looking into transdermal applications.
Right. So just to kind of follow up on that, and this is a question from Bridget, if you are buying a transdermal solution, a salve, an oil, something that you apply to your skin, is it more likely to have THC or more likely to have THCA? Meaning, are these salves decarboxylated before they hit the market?
That's another, I would think they would probably be decarboxylated. To be honest, I mean, in Canada, we don't have the wide selection of products as the States have. But I think because how little is known about THCA and CBDA, I don't think there's necessarily a market for that just yet. I would, if I were a retailer, I would certainly be decarboxylating it still, because I mean, I really don't think it's common knowledge to say that THC and CBDA have effects, right?
Right, absolutely. Okay, this is another one from Chris talking about sublingual bioavailability, and there was some confusion if it's alcohol or if it's oil-based. Does that make a difference in how it's absorbed?
Yes, so tinctures are what would be considered alcohol-based, right? So again, we don't have tinctures in Canada. The sublingual mist that we have is definitely an emulsion that's oil-based, and it's emulsified with water or with something that's aqueous. So these are all areas of research that we're very much interested in. Even when we look at, not just looking at alcohol-based or oil-based, but even the types of oils that we use. So right now, typically cannabis oil is made up of coconut oil or any medium chain triglyceride oil. So just to kind of give you an idea of where we're at in terms of that research, I mean, we still haven't even looked at the different types of oils and how that would affect bioavailability. And so, you know, I unfortunately, I mean, there's going to be a trend here. We don't have the answers to, you know, to say
A
that
lot of our
the oil,
questions. Yeah.
right? Yeah.
Okay. So Allison had a question about whether or not in your research you've come across any evidence that cannabis has a long-term effect on cognition. So we know that it does affect short-term memory loss, but I guess the question is, and feel free to correct me, Allison, if I've misunderstood, is does cannabis have a long-term effect on your memory
So,
or cognition
so
in
what we
general?
know now is that in the developing brain, and there is research on this, in the developing brain, there's MRI evidence to say that there are changes in the brain's structure. And so certainly in the developing brain, you know, it does lead one to believe that it can have long-term effects. Of course, you know, dose makes the poison, right? But I mean, I think it's a risk that may not be worth taking, especially for, you know, younger individuals. There's also another study. This is an Australian study a few years ago. They followed individuals for, I believe, 30 years or so. This was a really big study, and they looked at long-term effects of smoking cannabis. And they also, you know, made sure to eliminate other factors, such as if they were smoking cigarettes and so on. So it's a very comprehensive study, and they found this is not looking at the brain, but other aspects, you know, in terms of lung health and cardiac health. They actually found that there were no significant impacts of smoking cannabis for a period of 30 years in terms of other physiological, you know, health conditions. But coming back to the whole cognitive effects, so definitely the results so far is showing that in the developing brain, it does have long-term lasting effects on the brain. Absolutely.
Okay, that's absolutely good to know. A question that came up from a few people in the chat is CBD derived from hemp versus from marijuana. Do we see different levels of bioavailability depending on the source or different effects?
To be honest, I don't think you would. The profile is different. I mean, CBD is CBD. Doesn't matter if it's from hemp or from cannabis. But the only thing that would potentially affect its bioavailability is the complementary compounds. So the entire profile of compounds, right? So we still don't understand. And you have to understand a biological system such as a plant is very, very complex. So to understand each individual minor compounds and how they may affect bioavailability is something that's very difficult to do. But you know, CBD, like I said, will not be different. But it's a matter of what else is in the hemp versus what else is in the cannabis that may have an effect when it comes to the absorption and bioavailability.
Okay, great answer. I think that clarified things a lot, is that there's really no difference between hemp-derived CBD and cannabis-derived CBD.
Yeah.
These ones come from Garrett. On edibles, bioavailability, we talked about, you know, food on a full stomach, that makes it more easily absorbed. But what about, you know, if your metabolism is slow or you're suffering from any number of gastrointestinal sort of issues? We can even extend that to Crohn's colitis. How does that really affect the bioavailability when you've been using an edible specifically?
So you would definitely. I mean, it really depends on, you know, on the issue, right? So if you are someone who has low metabolism, then certainly you might experience the effects a little more delayed than others. If you're an individual that doesn't produce a lot of bile, for example, and that's the key emulsifying agent, you know, that's really the rate limiting step when it comes to absorbing THC and CBD. If you have very low bile, that's also going to have a drastic impact, right? So it really depends, I mean, on the individual and the issues that they're having with their digestion, I would say.
Oh, okay. And then the last one from Garrett. And by the way, everyone, if you have any more questions and I didn't get to them, please feel free to retype them for me because it's quite a bit to scroll. So let me know if I missed something. It's about weight and size of a person and transdermal absorption. I know that's not something that's had a huge amount of research done on it. You know, a petite young woman versus, you know, a large man,
Right.
medicating, you know, they have a knee that they try and apply salve to. Should they be using the same amount? Does size or weight affect how you absorb through the skin?
Yes, absolutely.
Okay.
Yeah, I mean, so if we're talking about transdermal patches, those patches, they can't enter the bloodstream. So yeah, that would definitely be something to consider. The size of the patient. If we're talking about lotions and balms, that has less of an impact.
Okay, great. Good to know. I noticed also, everyone, there are a few questions about how best to decarb, temperatures and methods. That's something that we did discuss in our last webinar. Feel free to hop on our community, which is community.salecannabis.co. You can watch the recording, ask any other questions. And if you have any more questions for Peter, you can also have them on the community as well. Oh, I see that there are quite a few questions that came in. Geneva is asking, is the synthetic cannabis the government produces safe? Have you done any tests that compare synthetic versus natural cannabinoids and the
Um,
absorption?
so I don't know. Maybe that's an American government because like the Canadian government, we don't
Potentially.
produce it. Yeah. Is it safe? Uh, I mean, I would say that the FDA in the states would have done the testing necessary before making it available to patients in terms of its safety, but efficacy would be a whole nother issue when it comes to synthetic THC. So we know that when you take a pure compound like THC, it doesn't have the same effects as when you take a whole plant extract. And so it's something called the entourage effect or the synergy that's created when you have other cannabinoids, no matter how minor they may be. So we know that, again, like I said, when you take the whole plant extract versus just THC, the effects are very different.
Okay.
So,
Yeah.
yeah.
Now, another question coming from Lorna is, so you're testing, plasma levels. So someone, let's say, consumes THC, vaporized or edibles, you test their plasma levels. Have you done this longitudinally, and has the bioavailability changed as a result of regular use?
That's a great question. So, well, we certainly haven't looked at this. I haven't come across any studies looking at this, but I do know if we're not talking about just the bioavailability, long-term use can certainly have an effect on how it's received in the brain. And so they have found that with long-term use, our brain is very plastic, right? So neuroplasticity causes the brain to kind of change over time, especially if you're smoking a lot of cannabis for a long period of time. So we know that, I've mentioned there's a lot of anti-anxiety effects to cannabis, but over time they actually found that it can make people more anxious and induce panic attacks. And this typically occurs with high concentrations of THC. They don't see the same effects when it comes to CBD. So when they have tested this on animal studies with high doses of CBD, the worst outcome was that it was no longer able to produce an anti-anxiety effect. But when they tested high doses of THC, it would do the opposite in that it would induce anxiety. And so so anyways, I can go into the details about that, I suppose, but it's essentially,
Hmm.
there's a buffering that takes place in your brain, and over time you're kind of the receptors are losing that buffering capacity to a point where the effects are no longer the same.
Okay, so this kind of falls on the heels of that question. It's from Deb, um, especially in terms of edibles and using edibles. What can you do to avoid creating like a tolerance? Like, should you take a break from your CBD oil, for 3 days out of 7 a week in order to better increase absorption? Is there any research on that front?
Um, I don't believe there is. If are we talking about like microdosing? Because that is
That's not what she mentioned specifically, but
okay.
she just said to avoid creating a tolerance, is it important to rest or to take days off from medicating when using edible?
I don't think that's necessarily necessary. I don't. There's not enough research to
Hmm.
really support that statement just yet. Yeah.
Okay. And this, I'll just take this last one from Lorna. Does a water-cooled pipe smoking reduce the versus smoking a rolled joint? And I think from what you said, not really.
Yeah, I don't think so. I mean, I'd have to think. I mean, there's definitely no research on this. It's purely sort of, based on logic and anecdotal evidence, I suppose. But
Right.
I mean, water would not dissolve THC or CBD, so there's no risk of losing any of the active ingredients in the water.
Yeah.
So, yeah,
No
if
difference,
anything,
bottom line, or lack of
bottom
research
line,
to
no
support a
difference. Yeah, I
difference.
don't think so.
Okay. Peter, thank you very, very much for talking with us today. I hope you all at home learned quite a bit from him and his research. We want to encourage you to continue asking your questions on our community, community.salecannabis.co. Um, and I hope you all have a great evening or day wherever you are in the world today. And like I said, join us on salecannabis.co. Our community's there. And if you have any questions, feel free to ask them. Thanks again, Peter.
No problem. Thank you.
All
Thanks,
right.
everyone.